Assalamu alaikum. Without further ado, but my webinar today is about, in short, GAIAS, Geospatial Artificial Intelligence Addressable Systems. It's an emerging combinator for growth, and basically how geospatial and AI interact together. Okay, so the agenda quickly, I'll go over a quick introduction, then we'll talk about geospatial artificial intelligence addressable systems, applications, some of our experiences, and then speak about our new technology or future process called ARIM. Introduction, Engineer Reem just said everything I wanted to say, so that's, I can skip that. A quick overview of Falcon Robotics. We are a solution company providing AI solutions in the space of aerospace, aeronautics, data capture and visualization, emergency management systems, health and wellness, inspection security, and training solutions. We have different tools, but we provide different solutions. Geospatial artificial intelligence, basically, most of you probably know this, you are experts in GIS. It is a combination of spatial data science, machine learning, deep learning, and data capture, how that data is captured. AI is a big term, very broad. Everyone's speaking about AI. What is it? It's basically when the computer simulates or mimics human intelligence. That's AI in short. Computers make sense of the world around us. They start automating the process, and they can create scalable insights from big data. Forms of AI is autonomous systems, machine learning, deep learning. They're all types of AI. Alexa, Siri. My phone just went off. Alexa, and they're types of AI as well. Spatial data science. It is the intersection of data science and GIS, where we use computer techniques for that. When we have big data, we improve the data, we manipulate it, we analyze it, and we visualize it to get actionable insights. That is basically spatial data science, and most of you are aware of this. But basically, we use computer techniques, I would say scientific methods, algorithms and systems to extract the knowledge or insights. Machine learning is basically algorithms enabling the machines to improve the tasks from experience. There's a machine learning style and there's the main task. Machine learning styles, you can say it's how you classify machine learning based on the style in which the model is trained. Trained with the data. There's supervised learning, unsupervised learning, aggression, and reinforcement learning. The first two, supervised and unsupervised, are the main ones. I'm going to speak about them a bit more, but the other two are a bit new and a bit complex. Machine learning task is what you're using the task. It's basically to perform different types of tasks based on the required approach and the type of data available. They can be divided into 6 tasks: classification, clustering, regression, associate rule, dimension reduction, and generative modeling. Again, the top 3, classification, clustering, regressions, are the main ones that are quite known, and I will speak. The 2 different main styles of learning, in short, is you develop predictive models based on the input and output that you have provided to the model. And the tasks that are associated with supervised learning is classification and regression. Classification is as simple as your email. When it classifies your mail, whether it's spam or not spam, that's a type of classification. Regression is when it regresses or separates data based on previous learning. For example, in predicting weather forecast, predicting traffic, this is regression. Unsupervised learning is when it groups data based only on input. Basically, it groups, which is clustering is the task for the unsupervised learning style. You group objects based on similarities. So objects with high similarities are grouped together, and with lower similarities are grouped together. This is the different task of machine learning. When we combine classification, regression, and clustering, we basically are tapping into deep learning. Deep learning is, I would say, an advanced type of machine learning. It's inspired by the brain, how the brain basically functions. Well, on the image on the left, we've all seen this complicated networks and stuff. This is basically how our brain works, and deep learning is just inspired from how our brain fires neurons in neural networks. The nodes, the circles, is just like neurons, how they work, and they follow the network. The input goes to the network, go to hidden layers. Hidden layers are basically different concepts, and it will go to each one and come up with a more complex concept. In short, it learns how do I put it? It learns without much input from the humans. That our brain has billions of neurons and neural networks. This is a much simplified. Our brain, and as humans, we have emotions, we have feelings, but the machines do not. And that's the difference why we cannot really imitate the brain, but this is as much as close as we can get. And it's very helpful when we want to get data visualization and for complex tasks. Comparison between deep learning and machine learning. And the main one is in machine learning, the human or manually you would have to label or extract the features of an object. For example, in the first one for the car, an expert would be extracting the features like the wheel, the tire, the windscreen, the body, and then the model would classifies it, and then you will get the output, whether it's a car or not a car. In deep learning, no, the model does that by itself, based on the hidden layers. It will group based on what it learned previously, what a tire looks like, what a window looks like, and it classifies them, and then that's when you will get the output. So the main difference is that in deep learning, the computer learns by itself. It knows the different parts of the cars, and basically reducing the time required, and human input is not required. Then we want to talk about data capture. It's obvious. This is the main or most known ways of data capture. Satellites, drones, cameras, at least for images or videos. Those are the main types of data capture. Satellites, I'm sure you're all familiar with them, drones and cameras. In Falcon Robotics, we don't have our own satellites. That's why we hopefully work with Mohammed bin Rashid Space Center and other satellite, try to get more access to satellite imagery. But drones is our expertise, and that's where we come in. Those are different examples of missions that we can do with drones. The first one on the left, it's done in an indoor setting. This is an autonomous drone. It doesn't require GPS. It can navigate by itself. You can do it indoors, but we can also use it outdoors. You can also use drones for 3D reconstruction and photogrammetry, whether it's indoors, outdoors, and again, this is all done in GPS denied environments. You do not, the drone navigates by itself. And again, this is done with our international partners. This is an example of where drones can come really in handy. For example, right now, a satellite, if we want to look at the ocean, satellites has a limited resolution. Let's say, for example, 100 meters. We want to see some objects within certain type of fish, some other species. Satellite cannot go all the way down. This is where we come in handy in Falcon Robotics. This is, for example, an autonomous marine drone. We can fly it. It flies by itself, actually, so it's autonomous. We can set it so that it does the whole flying for you. There's no human intervention required. You can also have human intervention, but the whole idea is that satellites are constantly taking images. We can use our drones to do the same thing and to constantly take images. Drone pilots, they charge so much, they're too expensive. With our solutions, it's autonomous. You do not require any human intervention. Other applications of geospatial and AI, crop count and health predictions. The input would be required as aerial RGB images that for the crop count. If you get multispectral images, and also you can also use those models to get crop health. You can also get growth and yield monitoring of crops. You would require time-lapse aerial RGB images, and also Earth observational data to understand the impact of climate change. And your output will be the recognition of plant growth stages, and you can monitor the crops and best irrigation time prediction. Input will be air temperature, humidity, soil temperature, moisture, rain. This is all data that you would have to input. Your output would be prediction of the best time to irrigate. Other applications, this is something that we can provide, but we haven't really worked on. For example, you can predict space weather using the models will be trained based on source images of sun surface, images from the sun surface from the satellites. You can predict space weather. You can predict that will help you knowing the drag on satellites, how if there's going to be any disruption, you can use that. Another application is traffic maps. You're all familiar with that. It uses the same concept. You can also predict crime rate, and it's all based on spatial machine learning. Another model or another application would be effective aircraft and object detection. You can there's usually just using normal satellite. It results in high miss detection rate and false alarm. Using convolution and neural networks, you can and GAIAS, you can actually get more effective aircraft and object detection. This is one of the first projects we worked on in MBRS. I think are aware of it. Sprung tree detection from RGB aerial imagery. We have this project. We had large amount of images, RGB images. They consist of 250,000 boundaries, and we had to build deep learning or machine learning model. We were provided with 5 images. We had some challenges. I'm just going to walk you through the whole project, how we did it manually and what our next step is. This is why I'm going to go over the whole process. So we had only like 5 days. The data was unlabeled, and the images were huge, like 64 by 64 kilometers. That's huge. No model can work on this large amount of images. We need data processing resources, and we had to work 24/7 in 5 days. So that's how many hours. Yeah. So the first thing we did, we split the team. We had members to manually label the images, annotate them. Basically keeping the label on images, differentiating palm trees from other trees or other vegetation. We used different models, deep learning models. 3 members were that. This was our we were trying with different models to see which one will give us the best precision. and we had one GUI to provide for us the output. We used 70% of the data for training, while 30% for testing. Some people use 80-20. It's just a method where people or data scientists use those kinds, 70-30, 80-20. We used 70-30, and it was good enough. The tools we used, QGIS is an open source remote sensing tool. It's that's where you can image the images, you clip them, you crop them. We use the deep learning models, RetinaNet, YOLO v5, UNet, I think GUI, but they're based on basically Python. ArcGIS Pro is a deep learning model, and it's built on Python and TensorFlow framework. It's a known remote sensing tool. Most of you are aware of it, and it understands satellite imagery and has the option, which is at the SSD, to detect objects. Pre-processing, as I mentioned, we took the images. They were unlabeled, so we started labeling them. We cut them, those images from 64 to 64 by 64 kilometer to 1 by 1 kilometer patches, and we started annotating them one by one. We used different deep learning models, but the best ones that we went forward with were RetinaNet and YOLO v5. RetinaNet is actually it's a deep learning model developed by TensorFlow. TensorFlow is a platform of neural networks. It's built by Google, by the way, developed to build your deep learning algorithms. YOLO v5, which stands for you only look once, is built on PyTorch framework. And obviously we use the GPUs in-house. I'm going to skip. This is basically just explaining RetinaNet. It's just to come. It's not something I'm very familiar with. We have our data scientists and experts who can. But basically, just to give you an idea, it's an algorithm built on PyTorch framework. ArcGIS Pro. So at the end, we got the best result from RetinaNet. We got an 89% precision. That's very good. We get 85 and above. That's very good, with an 86 accuracy, and 1/82 processing time. YOLO 5 gave us the second best result. ArcGIS just did not work for us. If we had time more changing hyper and training parameters, we could have got more results. But this was how we first started in, I would say, geospatial and AI. This was the results. The red dots indicate basically the latitude and longitude of each country. Additional results. Next, so we saw how much time it took us, how much effort, how we needed about 10 team members to build this in 5 times. Our next step is ARIM, which stands for Artificial Intelligence, Robotic Enterprise Integration Manager. This technology is basically a simple, autonomous platform for real-time data capture, data processing, and hardware control. It's going to be built on cloud or edge computing. The user can feed images to it, just upload the images, whether it's the drone users, satellite images. It will be able to visualize this data in real time. And based on our experience with autonomous drones and robots software, ARIM will be able to control your drone for you. For example, send it for emergencies, or in an industrial setting to fix something, or in AgTech, time for harvest. You start picking the fruits. It's going to be all managed by this platform, ARIM. Yeah, I guess this is what I had. much faster or finished much faster than I expected. But yes, this is Falcon Robotics. We like to work with people as an R&D partner and a technology integrator. Yeah, and I will give it back to Reem now.
Thank you so much, Engineer Ahmed, for your presentation. Sarah, it was very interesting. We will leave the floor now to our audience to ask questions. So please, if anyone has a question, drop it in the question and answer box, and Engineer Ahmed will answer your questions.
I just saw that I was moving my hands and the
Yeah,
headset. Okay, sorry about
it's
that.
fine. So please, everyone, if anyone has a question, drop it in the question and answer box, or you can type it as within the chat. So there's one of the attendees wants to ask a question. Please type your question in the answers and the question in the answers box. Okay, so we have a question
Q&A.
here.
Yeah.
Okay.
Can we use it for landslide? Yes. You mean a Reem? Yes. Can we use? There are other cloud computing softwares as well. Yes, you can use it for landslide. Yeah.
Okay, there is another question in the chat box. What about the regularity aspects of drone monitoring?
Regulatory. It's tough. Good question. Obviously, we had in the UAE, we stopped for a while. No drones were allowed. But right now, hobbyists are not allowed. That's for sure. But if you're a registered company, you can use drones. You need the permits, and yes, you can use the drones.
Another question from Arif. What programming language is best for machine learning?
What programming language is best for machine learning? To be honest, I cannot tell you what's best. Most models I would say are built on Python. But I can't answer that. I'm not sure what's the best for machine learning.
Okay. Moving to another question from Hamad. And the question, he wanted to know the number of levels and the computational power needed to run simulation. I think it's out of the scope of our webinar. Another question, what are the challenges you faced while working on deep learning, and what do you recommend to GIS remote sensing professionals to overcome these challenges?
I would say the challenge was when we had to do everything manually. We had a big team, and we needed many GPUs. They had to be running. That was expensive. We didn't have sometimes GPUs. I would recommend using cloud computing. There are many providers that would provide cloud computing. You can talk to us later. We can also work with you on such tasks.
Perfect. I think that's it for the questions. Dear everyone.
There's one thing in the chat. You provide multispectral images for quantity health monitoring purposes in UAE? Yes, that's something that we can provide. We provide multispectral images. We can use the drones if you have the permits. Satellite imagery, I think MBRSC would be able to provide that.
So for everyone who ever need anything or more further questions to the speaker, you can contact us on our email and we'll be happy to assist you. I think that's it for the questions. If no one has any other questions, I think, let me check for the last time. Yeah, I think that's it for the questions. So I believe that we can wrap up. So we came to the end of this webinar. Thank you all for your kind interest in attending this webinar, and looking forward to meeting you all in our next upcoming events. And thank you so much again, Engineer Ahmed, for your participation. It was a very great webinar, very interesting, and I think the audience has enjoyed this webinar. So thank you so much, and
Thank
have
you,
a
thank you.
nice day.
Thank you very much, Engineer Reem. Thank you for having me. There's actually one last question. I just saw it. Are you into drone manufacturing? Yes. Well, yeah, that was the right question. Again, thank you, Reem. Thanks to Mohammed Durash Space Center and the whole community of the Emirati Society of GIS and Remote Sensing. I look forward to more webinars to be part of the audience, and if possible, maybe host another one.
Inshallah, definitely. Thank you so much, everyone. Have a nice day ahead, and goodbye.
Goodbye. Bye-bye.